We're going to discuss the Chapter 8 test review. Start with problem number 1. We're asked to factor the monomial using prime factorization. We take 54 and factor it down. First thing I did was break it up into 27 times 2. 2 is prime, but 27 is not. 27 will break up into 9 times 3, and 9 can break up into 3 times 3. So the factors of 54 are 3 and 2, and it's made up of 54 can be written as 3 squared, or 3 to the third, times 2, and then you have a to the fourth times b squared times c to the third times d. Number 2, we're asked to determine the greatest common factor of the terms. Using the prime factorization of each term, you see that 66 can be written as 11 times 3 times 2. 78 can be written as 13 times 3 times 2. And 24 can be written as 3 times 2 to the third. So written out in their prime factorization, we look at what they all have in common. They all have a 3. They all have 3s. They all have 2s. They all have a's. They do not all have b's. This term does not have a b, but they do all have c's. So the greatest common factor, you have to look at your 3's, and we can't take any more out than whoever has the least. So they all have 3 to the first power, and they all have, this one is 2 to the first power, 2 to the first power, and 2 to the third power. But since they don't all have a power of 3, we have to go with the smallest power, which is 2 to the first power. When you look at a's, we have an a to the 12th, and a to the third, and a to the 9th. We have to use the smallest power, a to the third. And then we look at c, we have a c to the first, a c to the 9th, and a c to the fourth. So our smallest is c to the first. So then we wanted to evaluate what 3 to the second would be. That would be 6a to the third, c. That would be the greatest common factor between the terms. And number 3, when you look at their prime factorization, after you factored them out, what do they all have in common? They all have 2's in common. They all have at least 3 as their exponent. So we'll use the smallest of all of them, 2 to the third, smallest of all the 2 bases, and they all do not have a 3 in common. They all do not have a 5 in common. They all have an x in common, and they all have at least x to the 6th. So that is your greatest common factor. So now when we're asked to factor in 4, 5, and 6, we use the greatest common factor of them, and if they don't have a greatest common factor, then we look to see whether we can find 2 binomials that multiply together. So for number 4, when we look at the standard form ax squared plus bx plus c, then for number 4, a would be 1, b would be -1, c would be -110. So to factor, we're learning how to factor by grouping. We take a times c, which would be -110, and over here we look at what b is, which would be -1. And we're looking for 2 numbers that will multiply together to give us -110, but they will multiply together to give us -110, but and you combine them together, you get negative 1. We find out that negative 11 times 10 is negative 110, and negative 11 plus 10 is negative 1. And so we use that information to help us factor. We have the x squared, and we're going to change negative x into negative 11x plus 10x, and then we have minus 110 that we also bring down. And so what we do is we try to analyze the two groups of terms and try to factor out something from each group. For these first two terms, they both have an x in common. When I factor out the x, I get x minus 11. Over here, they both have a 10 in common. And if I factor out the 10, I get x minus 11 as well. So my factors, my common factor in between these two sets are x minus 11. They both have an x minus 11 in common. When I take the x minus 11 off, I'm left with an x, and when I take the x minus 11 off of that, I'm left with a plus 10. And so the x minus 11 times x plus 10 is how you factor, are the factors, two binomials that factor from x squared minus x minus 110. Number 5, we'll go through the same process, except if we look at the numbers, they all are divisible by 2. So we can decrease the size of A, B, and C by dividing everything by 2. So we get negative 2x squared plus x plus 62. So we'll go through the same process we went through above. We'll look at things that multiply together to give us A times C, which would be a negative 124, and they have to add up together to give us 1. After factoring through on negative 124, my only factors are 62 and 2, or 31 and 4, and both of which will not give me a 1 when I combine them together. So I'm going to actually stop with this answer at this point. Number 6, I look at this set of terms, I see that the middle two terms could cancel out. And so if they do cancel out, I can factor this two ways. I can factor them as they are and do factoring by grouping and take an x out of both terms, and then here take a 12 or a negative 12 out of both terms. But also, if I cancel out the negative 12x and the positive 12x, I end up with x squared minus 144, which are both perfect squares. And when you have a difference of two perfect squares, you put the square root of the first one first in both sets of parentheses, and the square root of the second one second in both sets of parentheses. One term will be addition, one term will be subtraction. And to check your work, you go back and FOIL this out. You get x squared minus 12x plus 12x, which is what I had in the original problem. They cancel out. And then 12 times negative 12 will be a negative 144. So that's what I ended up with. Is what I started with, so I know I'm correct. On number 7, I noticed that both terms are divisible by 5x squared. So 5x squared times x squared gives me 5x to the 4th, and 5x squared times negative 9 gives me negative 45x squared. So that would be one step, or the first step would be to simplify that, but also once I've done that, I I also notice that I have a difference of 2 squares in x squared and 9. So the square root of x squared is x. The square root of 9 is 3. One's going to be addition, one's going to be subtraction. And number 8, both terms have at least an x to the 7th. I'll take out x to the 7th. I'll have x to the 2nd, because x to the 7th times x to the 2nd gives me x to the 9th. And x to the 7th times 1 gives me x to the 7th. That'll be subtraction. I also, again, have a difference of 2 squares within my parentheses. One is a perfect square. So in addition to the x to the 7th, that will also factor into x, 1, 1, 1's addition, 1's subtraction. On number 9, if you look closely, these are also, again, a difference of 2 perfect squares. The square root of 9x to the 6th is 3x to the 3rd. So that becomes 3x to the 3rd here, and here, 1 and 1, 1's addition, 1's subtraction. To determine the values of k so that x squared plus kx plus 4 can be factored using integers. Okay, well, x squared plus kx plus 4 means I need two numbers that are going to multiply together to give me 4, but add together to give me k. And they all need to be integers. The only way to get 4 is 4 times 1, or 1 times 4, and 2 times 2. So k would be 4 plus 1, which would be 5, or 2 plus 2, which would be 4. So k could be 4, or k could be 5, and I could still factor it. If it was x squared plus 4x plus 4, it would factor into x plus 2, x plus 2. But if it was x squared plus 5x plus 4, that would factor into x plus 1 and x plus 4. When I'm asked to solve by factoring, and I know that I have three things multiplied together and they equal 0, well, 6 can never be 0. So d minus 11 would be 0, or 4d plus 7 would be 0. And to figure out what values of d would cause this to be 0, I would add 11 to both sides. d equals 11. Over here, I would subtract 7, and then divide by 4. So d would be negative 7 over 4. Those would be my two answers. On number 12, I need to get everything on one side, so I need to set it equal to 0. So the 2a squared minus 7a, I'm going to make it plus 3a, and minus 2 equals 0. So I just subtracted 2 from both sides and added 3a to both sides. Then I combine my like terms. I get 2a squared minus 4a, and these two, minus 2 equals 0. Everything is divisible by 2 now, so I can factor a 2 out and get a squared minus 2a minus 1 equals 0, which factors into 2, and I need two numbers that will multiply together to give me negative 1 and add together to give me negative 2. How about negative 1 and positive 1? Wait, okay, let's try something else. At first I thought it might be obvious that it would be negative 1 and negative 1. However, the problem is that negative 1 times negative 1 doesn't give me a negative 1 like I need. The only factors of negative 1 are negative 1 and 1 and positive 1. And when I add them together, I get 0 either way. So we're going to need to stop at that point. And this is going to cause a problem because I can't stop at this point and actually find values for A without factoring. So I'm guessing there might have been a misprint. I'm going to say someone should have made this a -2 or had the equal sign here and the minus sign here, and that would have made it a plus sign there, and that made it a +2, and that would make it a little bit easier to work with, because then we could say it's -1 and -1, which would add up to -2. So if it becomes a +1, then everything comes out nice and neat. But if it's a -1, in other words, if this was a -2 here and here, then we really can't factor it anymore, and it becomes prime at this point if this is negative. Number 13, 8x squared, and we need to subtract 1 from both sides. We get -512 equals 0. And I wonder if 512 is divisible by 8. Let me go to my calculator. Find out that it is. 8 is a common factor of 512. I get x squared minus 64, which is 2 perfect squares. So that breaks them into x and x, 8 and 8. Square root of 64 is 8. One's addition, one's subtraction. So for that to be 0, 8 can't be 0, but x could be -8, and that would cause this to become 0. Or x could be +8, which would cause this part to become 0. So either one of these two solutions would give me a 0 result. Number 14, again, let's set it equal to 0. So 10x squared minus 5x equals 0. And then they have a lot in common. Take out a 5x from both, and I'm left with 2x minus 1 equals 0. So, and I can break this up and say, okay, 5x could be 0, or 2x minus 1 could be 0. One of those two being 0 would cause me to get a 0 result. So 5x equals 0 means x would have to be 0 for that to happen. And 2x minus 1 equals 0 means I add 1, I get 2x equals 1, then divide by 2, x could be a half. If x was a half, that would cause this part to be 0, which would give me a 0 result. So x could be 0 or x could be a half. So as I go through and I evaluate all of my, well, number 15 is I evaluate all my factors of -60, I will see that none of them will add up to a -13. So okay, this is prime, and I can't factor it, which means it has no real solution, but it's prime. Number 16, I need to evaluate x plus 4 squared, x plus 4 times itself. Then subtract 25 equal to -16. So that becomes x squared plus 8x plus 16 minus 25 equals -16. Let's set it equal to 0. Okay, add 16 to both sides, and then subtract 25. So x squared plus 8x plus 32 minus 25 is 7, equal to 0. So I need two numbers that multiply together to give me 7, add together to give me 8. Well, that's going to be a lot easier. I got x plus 1 and x plus 7 equals 0. So the two numbers, possible values of x that'll give me 0 is a -1, which will cause that to be 0, and x being a -7 would cause that to be 0. Here we have a drawing for number 17. It's got an area of 180 square feet, and area is, the formula is length times width. In this case, our width happens to be 3 less than the length. So if area is length times width, I can take the width out and replace it with something equal, which is L minus 3, length minus 3. So that's length times length minus 3. And we know that the area is 180. And when I distribute, I get L squared minus 3L. And if I set it equal to 0, I can put 0 on either side. I get L squared minus 3L minus 180. If I factor that, I need two numbers that will multiply together to give me negative 180 and add together to give me negative 3. And after a little bit of searching, I find 15 times 12 gives me 180. So if I do negative 15 times 12, I'll get negative 180. Negative 15 plus 12 gives me negative 3. So that means that to get 0 would require multiplying L minus 15 times an L plus 12. And that would mean that L could be a positive 15 or L could be negative 12. But since we were talking about the length of a rectangle or the length of a room, we can't really use a negative number. So that one is not a realistic solution. So the length being 15, let's test that out. If the length is 15 and the width is 3 feet less than the length, and that would cause the width to be 12, and 15 times 12 does come out to 180. Okay, so the width is 12, length is 15. All right, 18, if we want to find the product of two consecutive integers, and you give one of those integers a name, like x. And if it's the product, it's going to be the multiplication of two consecutive integers. If the first one is x, then the next consecutive integer is going to be x plus 1. And we want to know that if we're told that the product of the two consecutive integers is 20, then we need to find two numbers that are 1 apart and multiply together to give you 20. And you probably do this by guess and check, but using algebra and using some of our factoring skills now. It's going to be x squared plus x minus 20 equals 0. So that's going to factor into x minus 5 and x plus 5 and x minus 4. Those numbers will multiply together to give me negative 20, and when you combine them, you get positive 1. And the way you would get 0 is that x would be have to be a negative 5, or x would be a positive 4. So if your first integer is negative 5 and you add 1, then your next integer is negative 4. So it could be negative 5 and negative 4 could be your two integers, or if your first integer is 4, then your next integer is 5. So it could be positive 4 and positive 5. Either way, you'll get positive 20, and either way, they are consecutive integers. Okay, since 144x to the 8th and 9 are both perfect squares, and I can break that up into 12x to the 4th minus 3 and 12x to the 4th plus 3. And down here, I'm looking at two numbers that are going to multiply together to give me 1/4 and add together to give me negative 1. So a fourth, how do I get a fourth? Well, half times a half, or negative half times a negative half. And these two, you do negative half plus negative half, you get a negative 1. So that's what it's going to be, x minus a half, x minus a half. Now 21 is a sum of two perfect squares, which is going to be a little bit different. Now, if I wrote this with a b, the x squared plus 0x plus 25, then I need two numbers that will multiply together to give me 25 and add together to give me 0. The only way to get 0 when you're adding is for one of them to be positive and one of them to be negative. And if one of them is positive and one of them is negative, you'll never get a positive 25 when you multiply. So this one's going to be prime. Down on 22, find out that 6 times 7 is 42 and 6 plus 7 is 13. So we can do 6 plus 7 times 6 plus, or x plus 7 times x plus 6. Number 23, I know we could put these two terms together, but we're really going to try to see if that is, since they wrote it that way, if we can factor by grouping using the information that they just gave us. So if 4 and negative 12x, what do they have in common? 4x squared and 12x, you can take out a 4x from each of those and get x minus 3. And if you take out a negative 1 from x plus 3, you get x minus 3. So both of them have an x minus 3 in common, and I took that out of a 4x and a minus 1. The bottom, break that up into x and x, and to get 2y to the fourth, we'd have to do a 2y squared and a 1y squared. But if we wanted to get it negative 3, they'd have to both be negative. And to check that, you would find out that that's x squared, that's minus xy squared. From negative 2y squared to x, you get a negative 2xy squared, and then the last terms, when you multiply those together, you get your positive 2y to the fourth. And these two middle terms are like terms, and they become negative 3xy squared, like I wanted. So our answer is what is in red. So taking out one piece at a time. Here's the answer. Get that out of the way. There we go. Last problem. A is 5, B, C is 6. So we need them to multiply together to give me 30. Backing up again. And they need to add together to give me negative 13. Okay, so two numbers will multiply together to give me 30 and add together to give me negative 13. 6 times 5, 12, no, 6 times 5, let's see, 30. So 6 times 5 is 30, 10 times 3 is 30. There we go. And so if I did negative 10 and negative 3, and I added them together, I would get a negative 13. Let's go with that. So the 5g squared, we'll take the negative 13 and make it a negative 10g plus minus 3g plus 6. And the first two terms have 5g in common, and I'm left with g minus 2. The last two terms have a, I'm going to take out a negative 3 so that I also get a g minus 2. So they have g minus 2 in common, and 5g minus 3 is the result.